Hello, this is Jason with LMGI. Today we're going to take a look at making operation models for this simple little part. I'm going to close the part. I'm going to start a new empty file using the correct units. And we're going to use our insert part copy. This will create a linked copy of the finished part. We don't want the material, and we do want this to come through as construction geometry. You'll see why in a moment. And we kind of don't want the material color to show through, so we're going to turn that off and then just apply. Purple is kind of the default for construction geometry. And then just go ahead and finish. Now we can model what would be probably the very first operation. The raw material is if it would, this might be the saw operation. So we'll just model a simple cylinder of 1-inch material. I've used the non-symmetric extent just for convenience, and we'll give it maybe 1/8 of an inch material on each end. I'm going to just key off the end. This is the benefit of having the finished component always available to work with. And let's set the material to be whatever the appropriate material is. But then we can't really see through the material, so we can override the style that came from the material using the color manager and choose a material we can kind of see through, which I like. I like to be able to see the finish component inside of my current operation. And then we're just going to name this operation 10, whatever you use for a naming convention, and then we can just close it. Then we simply repeat the process for the next operation in the sequence. Again, we'll do insert part copy, pick the previous operation, but this time on the dialog we do want to link the material so that one material, and we want to check both design and construction. So we'll get two bodies. One is the finished part, which will always ride along with every operation, and then one represents the raw material. I'm going to rename the finished part. It might get a little confusing, and then you want to set the body as the active body so that we can now cut that. And we'll do a simple revolved cut. I'm going to use our include command. Again, the benefit of having that finished part as a reference is awesome. You can work to that, and if the finished part design changed, it would ripple through all of your operations. It's just very convenient. And of course you can make independent drawings of each one of these parts because they're just part files. And you can turn off that finished part display anytime you want. We'll just save this second operation as op 20. Usually people go 10, 20, 30 to give them space in between in case they later decide they needed to add an operation in between 10 and 20. They can add a 15 if the process needed to have that modification later. So here again, this is redundant. This is rinse and repeat. We're going to again turn on the link the material, turn on both, apply, and now we're ready to do maybe a milling operation. I guess, renaming the bodies is helpful. They don't always come in a logical order. That might be a better way to do that, but that's what I did for now until I find a better way. So what are we gonna do here? Simple cutout. So this would be the slotting operation, and we'll just trim that up. So there's our little milling operation, and that looks good. I probably Probably should do a through all to be proper. No, dual symmetry through all, except I guess we just needed to cut the one body. There's really just that one solid body, which represents the kind of the in-process workpiece. You might think of it that way. So there's a mill, and we'll save that and give that a name. Next, we're going to look at how you deal with the issue of inserting an operation in between. Maybe you forgot to do an operation, or you ran a part and they wished they had the sequence a little bit differently, things like that. Before that, let's just take a look at, if you needed to make a change. This kind of demonstrates the associativity, the linkage between the components. I obviously forgot to put the hole in this turning operation, so we're just going to go ahead and put a drilled hole in there. I couldn't remember what diameter it was, so we're just going to add a hole, simple drilled hole. And this modification, so this is a case where I forgot to put a drill, but we're not inserting another operation, but I forgot to add a drilling sequence in that step. So that's easy enough. You just simply open up that file and you make your modification, and you'll see how all subsequent operations will update automatically. So there's our little hole, and I think it's a little nicer when you don't have that Z fighting of the two bodies, the zebra stripes that you get there. That's the graphics card fighting to decide, which one to show. But you have freedom to turn those on and off at will, and we're just going to resave that because we already made this one. And then we've kind of gone back to the last operation, and it's asking me, how do I want to update this? And I'm going to choose automatically all the time. So you see that the drill hole now showed up for me. So now, let's say we need to insert an entire operation, not just modify one. We're going to do the same sequence, and we're going to insert this in, or we're kind of saying insert after this operation the one that I forgot, or the one that I want to add. And it's really the same. It's exactly the same as we've done so far. We've set the material to be inherited and linked. And we renamed the bodies so we don't get confused as to which one's the finished part and which one. One of them needs to be activated, and if you don't know, activated in multi-body means that's going to be the recipient of cuts and protrusions and things like that. It's kind of your target. So this is an example of, we wished we had maybe turned this back end prior to the other turning operation. So we're just going to do a revolved cut, and of course I forgot to choose my revolve axis, as I do sometimes. Software reminded me nicely. And then full revolve cut. I didn't like the way this was tailing off, so I added a little extra line there. I didn't want it to cut because in the real world we're just going to turn far enough to get into that belly or that undercut, and then that will be cleaned off in the next operation. So there, we added our turning operation that we didn't have, and I'm going to give this a name that reflects that it comes before the other turning operation. So now we have kind of a linkage issue we need to work out, where the next operation is referring to the wrong previous operation. And one way that you can do this, you see that it's not being reflected there. You go to edit links, and this is an easy way to see your linkages, and I'm just going to change the source of that link. You could probably modify your insert part copy as well, but I find this works really well. And then you save it, and now from this operation on, they will automatically recompute. So if I go and reopen, I guess that one is all set, and there's the final. You see that recompute. So there you go, operation models in Solidedge.